In this video, we want to evaluate this particular integral here involving a radical. If you want to pause the video and try it, go ahead. I'll be right back. Now, since this one involves a radical, in this case in the denominator, I look for a substitution, either a U, standard U substitution, or maybe a trig substitution. And after looking at this, I'm going to try to rewrite this in this form here. If I can write it in this form here, where I have some number squared minus the variable squared, that's going to equal to arc sine of U over A. And of course, you can derive this formula using a trig substitution, but most instructors will let you use it if you know it on a test or quiz or whatever. So that's what we're looking for, this setup here. So I'm going to look at the radicand here, minus x squared minus 4x. I'm going to factor out a negative here, and that'll leave me with an x squared plus 4x. So I'm looking at the expression then, put this in parentheses like this. I got a positive 1 here for the coefficient of x squared. So I know that if I want to complete the square and make this a perfect square trinomial, I take half the coefficient of the linear term x, which is 2, half of 4 is 2, square it, and that completes the square. X squared plus 4x plus 4 can be factored into x plus 2 quantity squared. So I'm actually adding, since I have a negative out in front, I'm actually adding a negative 4. So to keep it legal here, I add 4 over here. Now I have the same thing, because a minus 4 here with a negative out in front, and the plus 4 gives me 0, gives you back the original expression. So then this is going to equal to the integral of 1 dx. I just put dx here, and then in the radical expression, the radicand, I'll make that the 4, I'll put that out in front, then minus, and this is a perfect square here, so I can write that as x plus 2 squared. So in the formula we had a squared minus u squared. Now I could let u equal to x plus 2, but then du would equal to dx. So that's not going to do much. I can just leave it this way. But you can use a u substitution here and let u equal to x plus 2. But it's still going to come out to this then. I have it now in the form that I want. In the formula it was du here on top, and this x plus 2 was a u. So you can treat the x plus 2 like a u, or you can make the substitution like I said. But either way, the integral of this is going to be sine inverse, so I can use arc sine, and this is going to be u, which in this case is the x plus 2. So it's x plus 2 over a. In this case, a squared is 4, so a is 2, and then it's plus the constant of integration. So this is the final answer. By completing the square of the radicand and rewriting it, we use the formula. The formula that we use can actually be derived using a trig substitution. But here, to complete the solution to this, we completed the square of the radicand and then used the formula. Thanks for watching. We'll see you next time.